Everyone, and welcome back. It's Kira Garfolo with Greenville Tech's Math 155. Today we're going to cover section 4.6, which is the last section that you have in our text. It's miscellaneous metric units and an overall summary. Let's get started. So, way back at some point, you've talked in a science class about the concept of mass. And basically, mass is just the amount of matter or the amount of stuff that a body takes, okay? The metric unit for mass is the gram. So the base unit is the gram. You've seen, probably at the doctor's office or in a health app or something, kilograms, right? Kilograms are larger. We often use those in everyday applications. If you were going to weigh yourself, you'd probably measure in kilograms, okay? A milligram is small. It's often used in medicine and science, and sometimes we even use micrograms in science and medicine. And you can see that that's 10 to the negative 6 versus milligram being 10 to the negative 3. You can even go down to nano, things like that. But for most of what we'll do in this class, we'll talk about milli and kilo, kind of stay between those. English units for mass are most commonly our pounds and our ounces. So if you think about when a baby's born, they're however many pounds and however many ounces. As a side note, if you've taken a science class, you may pick up on this, that technically speaking, mass and weight are not the same, okay? Weight is dependent on the pull of gravity. We're not going to really get into that for this class. It's not the purpose of it, but mass is the same no matter where you are. So you'll weigh less on the moon, but you'll take up the same mass, okay? If that's something you'd like to get into, you can certainly ask a science professor. You can email me. You can probably do a quick Google search to figure out the difference as well. I'm happy to talk about it, but I don't want to take up a bunch of time talking about irrelevant things for today's very last lecture. Okay, so we've talked about mass. Now let's talk about temperature. So we talk about degrees in both metric system and the English system, but they're not the same degrees, okay? Degrees Celsius are the metric units, and degrees Fahrenheit are the English units. Okay, degrees Celsius has some key points that are easier. You'll see why it makes more sense. It's back to that 10 base kind of. In degree Fahrenheit, if we're just looking at it, seems a little bit more arbitrary. The two are exactly the same at negative 40 degrees. So that means that negative, of course my pen isn't working. Negative 40 degrees Celsius is the exact same as negative 40 degrees Fahrenheit. Okay, that's the only place that they are equal. So if you want to look, this is from your textbook. Don't get overwhelmed. I'm not going to ask you to memorize this, but I just want to talk about it. So the boiling point of water is 212 degrees Fahrenheit, which in Celsius is a perfect 100 degrees Celsius. That's no coincidence. It's back to that metric 10 base, okay? A hot day, if we want to talk about 100 degrees Fahrenheit, we use the English units here in the US. So, weather forecaster is going to say 100 degrees, and they're talking about Fahrenheit. That's 37.8 degrees Celsius. And if we talk about a normal body temperature, we'd say is about 98.6 degrees Fahrenheit, which is 37 degrees Celsius. There's some background here about those degrees and why it may not actually be 98.6. But again, that's for your information. I'm not going to test you on that or anything like that. You can see lots of other typical measurements here. The big thing that I would tell you is that the freezing point of water is 32 degrees Fahrenheit, which is actually a perfect 0 degrees Celsius. Okay, and there's a typo right here. This should be Fahrenheit. Okay, so 0 degrees Celsius is where water freezes, and 100 degrees Celsius is where it boils. You can see that 0 and 10 and 100 base right there, okay? Now, if we want to convert back and forth, some of you may have seen a different formula. You use 9/4 and 4/9 and all kinds of stuff. In our text, we have a nice and easy little simple formula. And this formula is also given on your formula sheet. So again, you don't have to remember it or commit it to memory, but definitely be familiar with how to use it. So no matter which way you're going, the first thing you want to do is add 40, okay? If you're going from Fahrenheit to Celsius, you're going to divide by 1.8. If you're going from Celsius to Fahrenheit, you're going to add 1.8. So typically, if you think about the freezing point of water is 0 Celsius, it's 32 Fahrenheit, or boiling point of water is 100 Celsius or 212 Fahrenheit. Think about that Fahrenheit being bigger. So to get it to Celsius, you need to divide it by something. To get it from Celsius to Fahrenheit, you need to multiply it by something, okay? So take these steps, and then whatever you get there, subtract 40, and that's your answer. So the only thing that differs, depending which way you're going, Fahrenheit to Celsius or vice versa, is whether you divide or multiply. Everything else is the same. Let's look at an example. So we've already talked about how the boiling point of water in Fahrenheit is 212, and that we know that in Celsius it's 100. So let's show that conversion. 212 plus 40, we add that 40. This is step one. And then we're going to divide it by 1.8 since we're going from Fahrenheit to Celsius, okay? That's step two. And then we're going to subtract 40 again, which is step three, to get our final answer of 100. Okay? Give it a try. Pause here, follow along, whatever you need to do. We're going from 15 degrees Fahrenheit to degrees Celsius. So we're going to take 15 and we're going to add 40, which is going to be 55. Okay, so that's step one. Step two, since we're going from Fahrenheit to Celsius, is to divide by 1.8. So 55 divided by 1.8 is going to give us 30.6. And lastly, we need to subtract 40. So 30.6 minus 40, and that will give us our final answer. This is going negative 9.4 degrees Celsius. Now let's think about this. It's negative. Does that make sense? Well, 15 degrees Fahrenheit is pretty cold. It's less than freezing, right? So yes, we would expect it to be in the negatives for Celsius because water freezes at 0 degrees Celsius. Let's give this one a try. We're going to go the other way. 40 degrees Celsius to degrees Fahrenheit. So the first thing we do is add 40. Next thing we're going to do, since we're going the other way, we're going to multiply by 1.8. So we're going to have 80 times 1.8, which is going to give us 144. And then we need to subtract 40. So our final answer is 104 degrees Fahrenheit. Get some practice with this, become familiar with this. It can be kind of tricky, but it's a lot easier than, in my opinion, than some of the other formulas we can use that are mathematically equivalent. Okay, now these units are here also for you for your reference. You do not need to memorize all of these, okay? But you do need to be familiar. If you look at the old tests that I've posted, you can get an idea of what I might ask, okay? I'm going to give you some units and say, well, are they metric or are they English? Are you measuring length? Are you measuring area? You know, what types of things are we measuring with it? The big thing that I would take note of is the metric. Notice it all has the same base, okay? We have meters here. We have millimeter, centimeter, kilometer for length, okay? It's all based on the meter. Remember, we have all those metric prefixes that 10 to the, -3, 10 to the -2, 10 to the 3, all those things. English does not follow those rules. We have inch, foot, yard, mile. If it doesn't make sense to talk about milli or centi or kilo, we don't talk about kilo inches, right? We talk about feet and yards and miles. So that's kind of a key that it's probably English if those prefixes don't work. Area, you're going to look for the squared, okay? Look for your squared if you're talking about area. You're going to have a length measure, okay? And you're going to square it. If we're going to talk about volume, remember that volume, you're looking for the cubed. I mentioned this in the last section. Look for a unit cubed. If it's a unit cubed, it's fair to assume in this class that you are dealing with volume, okay? For capacity, remember capacity is similar to volume, but we don't talk about cubed. It's how much something's going to take up still, but we're not talking about cubed units, okay? Fluid ounces, cups, pints, quarts, gallons, barrels, bushels, all of those are capacities. I'm not going to come ask you on a test about minim or bushels or grams. Okay, I've never used those in everyday language. I might ask you about cups or pints or quarts or gallons or fluid ounces or tablespoons or teaspoons. Okay, something that you know that you're measuring a volume, but you're not doing it in cubic. Okay, you're using capacity. Think about recipes. Back to the metric system again, liter is your base here. And you're talking about milliliters, centiliters, deciliters, decaliters, hectoliters, kiloliters. Notice those metric prefixes work again. And some more if we're talking about weight or mass. The big thing that I would focus on for the English system is going to be tons, pounds, and ounces. If you're dealing with the metric, gram is your basic. Metric ton is slightly different. I'm not going to ask you to convert between those, but we've talked about milligrams, grams, and kilograms in our class. And we've already talked about temperature. This says blank, really it's just a blank cell, okay? Our temperature for our English unit is degrees Fahrenheit, and for metric it's degrees Celsius. It's not really degrees Kelvin, it's just Kelvin. When we're talking about science, if some of you have taken a chemistry class or sometimes a physics class, Kelvin is used in chemistry a lot because it has an absolute zero. So zero means completely zero, okay? I'm not going to ask you about Kelvin either, but I will certainly ask you about Fahrenheit and Celsius. Okay, so there are some useful equivalents here that you need to know. And this is not usually given on a test, okay? You need to know that for water, all of this boils down to, for water, 1 cc is the same as 1 centimeter cubed, because remember cubic centimeters, what cc stands for, which is equal to 1 milliliter. This is always true, but for water, it's also equal to 1 gram, okay? So these are always true. This part is only true for water, okay? So if I ask you questions about water, you need to know that 1 gram is the mass for 1 milliliter or 1 cubic centimeter. You also can note that for water that 1 decimeter cubed, 1 cubic decimeter, is the same as 1 liter, which also is the same as 1 kilogram, okay? This is always true. The mass part is just true for water, okay? Certainly know this part, okay? This first one I would certainly commit to memory. Cubic centimeter equal to cc equal to milliliter equal to gram if we're dealing with water, okay? This is going to lead us into something that we call unit analysis. I called it in another class factor analysis, okay? Dimensional analysis, you may see different names for it in different science classes. Basically, we're converting units to other types of units, okay? In unit analysis, we are going to treat our units like variables, and we are going to want to try to cancel them out, okay? We're going to perform basic mathematical procedures, effectively multiplication and division, okay? So to do this, we're going to start with what we want to convert, and you're just going to leave it alone, okay? So we're converting 2 yards to feet. So we say, okay, well, 2 yards. What do I need to do to multiply that to get my unit to be feet? Well, I need to divide it by something yards. How many yards make a foot, or how many feet make a yard? Well, there are 3 feet to 1 yard, okay? Everything we're doing this, we're multiplying by ratios, okay? We want to multiply by a valid ratio, where that ratio equals 1, right? 3 feet to 1 yard is 1. 1 yard does equal 3 feet, okay? To cancel your necessary units. And whatever you're left with is what you're converting to. So here, yards cancel, and we're left with feet, which is the unit that we wanted, okay? Now, we can also use this to convert between English and metric units. We've talked about how to convert between different metric units using those prefixes, right? Well, we can actually use unit analysis to help us, okay? So if we wanted to convert 80 pounds to kilograms, knowing that 1 kilogram is about 2.205 pounds, when we start with what we are given that we're wanting to convert and we leave it alone. And we want to get it to pounds, okay? Or we want to get it to kilograms. So that means we need to divide pounds by pounds. So we put that on our bottom here. And we know that 1 kilogram is 2.205 pounds. So if we just multiply that straight across in our calculator, you could even just set it up like this and skip this middle step in your calculator. You'll get that 80 pounds is about 36.3 kilograms. There are some common conversions here. Most of these, any of the conversions that you need should be given on a test. I'm not going to make you memorize that 1 kilogram is 2.205 pounds, okay? But you can understand the English system, the exact and the approximates. 2 pints is a quart. If you've done a lot of cooking, you may know these. 4 quarts is a gallon, 16 ounces is a pound, 16 tablespoons is a cup, things like that. Between the two, an inch is about 2.54 centimeters. A teaspoon is about 4.93 milliliters, things like that. Again, you'll be given the conversions necessary, just know how to use them with factor analysis, unit analysis, excuse me. Okay, let's practice a little bit. Let's say that you have a rectangular box that is 150 centimeters by 7,500 millimeters by 2.5 meters. So the first thing you want to do is find the volume in centimeters cubed. Okay, so we're going to make this step 1, step 2, and step 3. Now, before we even get to step 1, notice that we want cubic centimeters. This one is in centimeters. Okay, this one is not, and this one is not. 7,500 millimeters, going from 10 to the negative 3 to 10 to the negative 2, is going to be 750 centimeters. And 2.5 meters, going from 10 to the 0 to 10 to the negative 2, is going to be 250 centimeters. Okay. So to get our volume, now that we are all in centimeters, remember that we're going to multiply length times width times height, or you can talk about the area of the base, so 150 by 750 times the height of 250. Either way, you're multiplying 150 centimeters times 750 centimeters times 250 centimeters. And that is going to give us a large number of 28,125,000 cubic centimeters. Okay. So number 2, this is our volume. If it's filled with water, what is the mass of the water in grams? Well, remember that 1 centimeters cubed equals 1 cc equals 1 milliliter equals 1 gram of water. So that means that we have this number of grams. So our mass is identical, just in grams. 28,125,000 grams. Okay. What about the capacity in liters? Well, using this same idea here, the first thing we want to do is convert it to milliliters. Okay. So we know, using this above, okay, that we have 28,125,000 milliliters. And remember that milliliters is 10 to the negative 3. To get it to liters is 10 to the 0. So we're just going to move our decimal place 3. We're going to a bigger unit, so we're going to go left. So it's going to be 28,125 liters. Okay, because we're going to move 1, 2, 3 decimal places. Okay, get some practice here. Make sure that you can get this. Okay, let's talk about some unit analysis for area and volume. Okay. Our conversion for a square unit can be squaring the conversion for the unit of length. Okay. So 3 feet is 1 yard. So if we want 1 yard squared, we actually get 9 feet squared. Okay. Because 3 squared is 9. Okay. If you're going to square this, you're going to end up with 9 feet squared, because remember that square applies to both. A cubic unit does the same thing, except you're going to be talking about cubing. So 3 feet is 1 yard, right? So if we want 1 cubed yard, we're going to get 27 feet cubed, because 3 feet cubed is going to be 3 cubed times feet cubed, which is going to be 3 cubed is 27 feet cubed. Okay. Now, if you're talking about square units and cubic units in the metric system, you can certainly use what we have already talked about in the area and volume sections, but it can also help you to think about 1 meter being 100 centimeters. So 100, we would move it 2 decimal places. Then if we're talking about square meters, we're going to move it 2 times that, so 4 places. Okay, so we're moving it twice as far. So meter to centimeter is 2 places. So meter squared to centimeter squared is going to be 2 times 2, which is 4 places. Okay. Cubic units is going to do the same thing, except you're going to do it 3 times. So meter to centimeter is going to be 2 places, as always. Meter cubed to centimeter cubed is going to be 2 times 3 places, or 6 places. Okay. Or you can use your unit analysis. Okay. There's a lot that you can do. There are multiple ways. There are ways that I have not actually discussed that always come up in in-person classes, of ways that you've learned or ways that you think about it personally. As long as it's mathematically sound, that's fine. There are a lot of mathematically equivalent ways to look at this, and perhaps you've done it in a different class that's a different way. Okay. Let's talk about converting 10 inches squared to centimeters squared, knowing that 1 inch is 2.54 centimeters. Okay. So 10 inches squared, we can convert it once, we can convert it twice. Okay. So you could also say, okay, well, I have 10 times 1 inch times 1 inch. So that's going to be 10. And we already know that 1 inch is 2.54 centimeters times 2.54 centimeters. Doing the exact same thing as unit analysis here. Okay. We're just not breaking it down mathematically the same way. And that's going to give us the exact same answer. Okay. But if you want to think about inches canceling with inches, you can certainly do that too, whichever way it makes the most sense to think about. 600 inches cubed to feet cubed. Remember that 1 foot is 12 inches. So if we have, you can do it in the unit analysis thing, remembering that 1 inch times 1 foot times 12 inch, 1 inch times 1 foot to 12 inch, and so on for those units. So you can cancel out your inches. Or you can think about it being 600 times 1 inch times 1 inch times 1 inch. Okay. And if you want to do it the other way, just be careful here, because we're taking about how many feet is 1 inch? Well, it's 1/12 feet for each of these. You are doing mathematically the exact same thing, and this will also give you 0.35 feet cubed. Okay. Now, I know sometimes students have a hard time wrapping their heads around this, and that's totally fine. Get a lot of practice. Let's take a moment and pause and see if you can practice this one. We're going to have 4 practice problems. Okay, so if 1 inch is 2.54 centimeters, convert 2 feet squared to centimeters squared. Well, you know that you have 2 feet squared. Okay. And so you also need to know first, we need to go inches. We're going inches to centimeters. We're going from feet to centimeters. The 2 feet squared, let's put it in inches first. 2 feet squared times 12 inches for 1 foot times 12 inches per 1 foot. So that's going to get us an inches squared. Then you need to get rid of those inches. So we need to do something for inches here, something for inches here. And we want them to be centimeters. So these feet are going to cancel off feet squared. This inch will cancel with this inch. This inch will cancel with this inch. We'll be left with centimeters squared. How many centimeters are there per 1 inch? Well, 2.54. So we have 2.54. If we multiply all of this across, we're going to get 1858 roughly. So 2 times 12 times 12 times 2.54 times 2.54 is going to give you somewhere around 1858. Okay. Now you could do the same thing that we've talked about before. If you want 2, you have times 1 foot times 1 foot. It's going to be the same as 2 times 12 inches times 12 inches. And that'll give you what? 288, I believe, inches squared, which is going to be 288 times inch times 1 inch times 1 inch, which is 288 times, hold on, 1 foot, 1 foot, 12 foot, 12 inch, 12 inch. Oh, I'm not wanting how many centimeters? 2.54 and 2.54. My pen is not working here. So 288 times 2.54 times 2.54 is going to give you this same 1858 centimeters cubed. So if you wanted to do it like we learned earlier, that's an equivalent mathematical way. You're going to get the same answer. 50 inches cubed to feet cubed. You have 50 inches cubed here. We know that we need to cancel out inches 3 times. So let's put 3 inches on the bottom. Okay. And we know that we want feet cubed. So we want 3 feet across. So there's our units sorted out because we know that this is going to cancel with these 3. We have to cancel 3 of them because we have a cube. How many feet are in an inch? Well, 112. So how many inches are in a foot? So 1 foot is going to be 12 inches. So if we multiply these across, we're going to get 0.03 feet cubed. Now you could do this the exact same way that we talked about before. Okay. Go ahead and get some more practice here. There's a couple ways to do these. $30 millimeters squared to meter squared. We're going to do that unit analysis. You're starting with 30 millimeters squared. Now you know that you want to go to meters and you need to cancel out millimeters twice. Okay, so they're going to be identical, but you know that you need to do this. How many meters are there to millimeters? Well, there's 1 meter to 1,000 millimeters, excuse me. So we have 1 to 1,000. And if we put this in our calculator, we're going to get 0.00003, so 10 to the negative 5 meters squared. Okay, that's our final answer. Or you can think about decimal places. There's like 3 or 4 different equivalent ways to think about this. Remember that millimeters to meters is 3 decimal places. So millimeters squared to meter squared is 3 times 2, which is 6 decimal places. So if we talk about 30, we need 6 decimal places. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, which is the exact same that we found above. Okay, so the same idea can apply. 15 kilometers cubed to meters cubed. Now we're going to cube. So we know that we have 15 kilometers cubed. We know that we have 3 kilometers over here, so we need 3 denominator kilometers here. And we want it to be meters, so we want 3 meters on top. We know that there are 1,000 meters per 1 kilometer. Okay. And if we multiply this across, we are going to get, calculator's going to tell you 1.5 times 10 to the 10 meters cubed. Okay. You could also think about kilometers to meters. It's 3 decimal places. So kilometers cubed to meters cubed is going to be 3 times 3, which is going to be 9 decimal places. So we're going down. So we're going to move to the right. So 15. We're going to move 9 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And sure enough, that's the same as 1.5 times 10 to the 10 meters cubed. Okay. Totally equivalent answers. Okay. So it's totally normal. A lot of students at the end of this section are kind of confused and a little bit lost. Take it one step at a time. Okay. You're just talking about conversions. Maybe you have another way that you prefer to do it from a science class. And again, I'm not here to tell you you have to do it this way, as long as it's mathematically sound and not just guessing or coincidence. Okay. One step at a time. Write down what you know, write down what you want to get, and you'd be surprised how much that can jog your memory of what you need to do. It can also show me that you might have known a little bit of what you were supposed to do when you're working on a test so you can get some partial credit. I would encourage you to know the basic metric and English units. Again, I'm not going for those far-fetched ones that we don't ever use in our real world, but you do need to know the basic. Okay. I'm going to ask you again, look at the old test and get an idea of what will be asked. And that's it. You have finished all of our sections for Math 155, so you should be very proud of yourselves here. Don't get too excited until you're done though, right? Make sure that you go back, get plenty of practice. Let this test be a great one. Okay, finish the class strong. A lot of students do, and I know that you can do it too. As always, use all the references, all the resources available to you in your text and the rest of the Blackboard shell. If you have any questions, you can ask the Math Center. You can always reach out to me. I'm always happy to help. Again, congratulations, study hard, and I will see you guys hopefully in another course. Have a great day.